Hello, thank you for watching this video on histograms and probability. The objective of this lesson is to interpret different data displays. And this goes along with the Michigan objective to represent data with plots on the real number line. On the number lines below, we're going to make a dot plot of each data set. We're going to find and mark the median, which, as you remember from middle school, the median is the middle number, just like the median is in the middle of the road. And then we're going to state the range of each data set, which is from the lowest value to the highest value. Let's get started. We've got a 1, a 2, 2 3s, 2 4s, 3 5s, a 7, 2 8s, a 9, 10, 3 6s, and another 7. It's not part of the lesson or the directions, but let's just say that this is mound-shaped because it kind of looks like a hill if you trace over the top of it. The median would be the middle number. So how many data points do I have here? 2, 4, 6, 8, 10, 12, 14, 16, 18 points, which means in between the 9th and the 10th one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median will be right between there, 5.5. I also could have found that by just walking my fingers in until I found the middle value. The range is from the lowest to the highest. The lowest value is 1, and the highest value is 10. Let's do set B. 1, 1, 1, 4 2s, 2 3s, a 4, 3 5s, 2 6s, 2 7s, 2 more 3s, 2 more 4s, 2 8s, 9, and a 10. This data set is skewed, meaning the data is kind of piled up on one side and then it sort of tails off. And when you want to say the direction of the skew, you say wherever the tail end is. And as this kind of pulls in this direction, we would say this is skewed to the right. How many data points are in this set? 25. So the middle value will be the 13th value from either end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There it is. The median value is 4. I should probably check it from the other direction. Yep. And then the range, again, is from 1 to 10. Moving on to set C. 2 1s, 2 2s, 2 3s, 2 4s, 2 5s, 2 6s, 2 7s. This one's boring. This type of data, when it's just kind of all the same height all the way across the data display, is called uniform. They don't have to be exactly the same height, but mostly the same. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So in between the 10th and the 11th, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right there, it is 5.5 again, and with the range of 1 to 10. One more. 1, 2, 2, 3, 3, 3, 4, 4, 5, 8, 9, 9, 9, 10, 6, 7, 8, 8. This data set has two sort of humps to it. We call this one bimodal. Bi for 2, and mode kind of like when you're looking for the mode of the data set where there are the most values. So 2 places where there are clumps of values. 2, 4, 6, 8, 10, 12, 14, 16, 18 this time. Yep, just rechecking because I had 20 up there, 18 this time. So the data set will be, let's see, in, right there, in between the 9th and the 10th. Yes. So the data set, again, has a median of 5.5 and a range from 1 to 10. I guess the moral of this story is that it really doesn't matter what shape your data have when you put them in a dot plot. They could have the same median. The shape doesn't affect the median, and the shape doesn't affect the range either. This one, the median was different, but that I think is because it had a lot more values in it than these. Even though it had the same range, the median of the data set was a little bit different. So the question down here says, do data sets with more data always have a higher median? Well, more data does not mean a higher median. This one has more data, but has a lower median. Set B has more, but a lower median. The next question says, do data sets with more data have a bigger range? The answer there is no as well. Set B has more data, but it does not have a bigger range.